In this video we'll be discussing the two different sizes of wheels and the amount of rotation it takes to cover the same distance, or what happens if a wheel's bigger and the two wheels rotate the same amount of times. So first off, let's just watch these two animations go along. We can notice how the top one seems to be making a lot more rotations than the bottom one in about the same distance. We see that in this amount of distances covered is one rotation, because it takes this small dot that's on the surface to travel all the way around. So each one of these bumps is one rotation. So in about the same distance, we can see that the small one did about a third of many rotations. The small one did 3 times as many as the big one. The big one did a third as many as the small one. So let's move on to a couple problems. So in the problem, we're discussing how far Lauren pedals. So Lauren pedaled as fast as she can and then coasts until it stops. After Lauren stopped pedaling, the bike goes 500 feet. How many revolutions did the bike wheel do while coasting? Well, we're going to look at a couple different things. So first off, we want to find out the diameter of her bike, which is given to us for 18 inches. And from that we can get the radius is equal to 9 inches. So with that 9 inches, we can then find the circumference, or the distance around the tire, of her bike. And we do it for this formula, 2 pi r, and we plug in it, solve, and we get 50.3 inches is the circumference of her bicycle tire. Now, we want to find out how many rotations, or how many times did this wheel spin for this bottom length to be covered of 500 feet. And we can do that a couple ways, but one way that we're going to just do is we have 500 feet, we turn into inches, because that's what our circumference is in. So we want to convert it to inches. Once we have our inches, we divide by the circumference, and that gives us how many times this circumference goes into 500 feet, or how many rotations, because each rotation is 50.3 inches. So the rotation of the tire going around, each one of these is going to be 50.3 inches. And once we have that number, we know the number of rotations. So Lauren does 119.3 rotations to cover 500 feet. Now, if we look at Carlton, the next one, Carlton has a 16-inch bicycle, which means that he has a radius of 8 inches. And we want to know if his rotations are greater or less than the number that Lauren traveled over 500 feet. So if we make the tire smaller and do it the same amount of distance that is traveled, you're going to get more and more rotations. So if I move this back, and if we look at what Lauren's was a little bit bigger, we can clearly see that Carlton, with the smaller diameter, the smaller radius, is going to travel more times than Lauren is in one of them. So let's count them. We have Carlton as 1, 2, 3, 4, 5, 6. Oh, I switched over to Lauren. Here we go. So 1, 2, 3, 4, 5, 6, 7. So about 8. We'll call it 8. So Carlton did 8. And if we look at Lauren, we have 1, 2, 3. So 1, 2, 3, 4, 5, 6. So Lauren did about 6 in the same distance. We can see easily this isn't 500 feet, but we can see that the amount of distance, whatever it is, Carlton did less than Lauren. Clear that. So the mathematics sides of this is we find out what his circumference is, and it seems that I have mixed these two up, so really, if you notice, there's 8 inches here, but really Lauren wants to be 9, so these two are reversed. So we'll just move it like this. Lauren and Carlton. Here we go. So Carlton, with the smaller tire, had 119 rotations. Lauren, with the bigger tire, if we work through it, we get the circumference is bigger. We get the number of rotations is bigger. So therefore, Carlton's tire spun more times in 500 feet than Lauren's did. So now that we know about bike tires, let's talk about car tires. We have two different car tires. One is going to be 16-inch rims, and the other one's going to be 18-inch rims. And we want to know if I had a car with 16-inch rims, so this one over here, 16-inch rims, and upgrade it to 18-inch rims, how much faster would it go? So what we're going to start off with is we're going to say with 16-inch rims, we are going to be going 60 miles per hour. And if we simplify that down to feet per second, it's 88 feet per second. So 60 miles an hour is 88 feet per second. 88 feet we turn into inches per second, so 1,056 inches per second. And then we just divide 1,056 by our circumference, and we get 21 rotations per second. So with an 8-inch tire, we get 21 rotations per second. So if we animate this, we notice that we get the rotations. So now we move over to 18-inch rims, and we talk about what happens when we have 18-inch rims. So we take the amount of rotations that it took over 60 miles per hour. So in this amount of distance, we made 21 rotations per second. So 21 rotations per second on 16-inch rims gives us 60 miles per hour. Well, let's see how many rotations per second, how many 21 rotations per second, how fast that is on 18-inch rims. So if we make our wheel bigger, we want the same number of rotations, so 1, 2, 3. Let's just stick with 3. So in 3 rotations, so we have 1, 2, and 3. So in 3 rotations with the bigger tire, we went a farther distance than with the smaller tire. So we can assume that it's going to be the same for inch rims. So with 21 rotations per second gives us this, for 56 circumference times 21 will gives us 1,186 inches. That many inches per second gives us 99 feet. 99 feet per second gives us 67.5 miles per hour. So 16-inch rims with 21 rotations gives us 60 miles per hour. 18 inches rims with 21 rotations gives us 67 miles per hour. So if you upgrade the rims on your car, the same amount of rotations is going to give you a faster speed.